Okay, fine. So we break. Fine. Okay, fine. So yesterday we have looked at functional interface. Okay. Fine. We know interface now. We know what is a functional interface. Right. So any questions related to what we did yesterday? Yeah. Any questions you have? Okay. Fine. Then fine. So then let's get started with the. So today what we'd like to do is we'd like to use a functional interface, right? We'll have our own functional interface, and we'll see how and where we can use in our application. See, what is our current application which we are doing? We have a class called account. Okay, fine. We made it abstract because we want to have subclasses. Okay? Fine. So we have created two subclasses. One is called the savings account, other is the current account. Right? Our account object has instance variables which are account number, name and balance. Okay, we have the methods for deposit and withdraw, and which will update the balance. Okay, that's a basic one, right? And then the subclasses are inheriting those. Okay, but in case of the current account, okay, we are managing a in the case of current account, what we have done, we have overridden the withdraw method, right? Where it's not like what happens in account. For every current account, we have to manage a what is the we have to see that it maintains a minimum balance. So we have declared a minimum balance as a static variable. That's a fixed value. Okay, but also there is a penalty in case there is a withdrawal where the amount goes, the balance goes below the minimum balance. Then additionally, a penalty is also to be deducted from the balance. Okay, and so that's how it is, right? Okay, the only thing here is we have this penalty amount being a fixed value, and penalty amount is currently a fixed value. Can we have it as a function? It can be a function of two things. It can be a function of what is the minimum balance that is required, okay, and the shortfall, what is the shortfall he is having. Okay, so if he is withdrawing too much, okay, fine, it's very less, then maybe the penalty has to be more. Okay, the minimum balance, it has less than minimum balance by a very little amount, maybe the penalty may be less. Okay, see, we may like to have it as a function rather than having it as a some fixed value only. Okay, it can be a function of the what is the new balance which he is having and what is the minimum balance which is required. Okay, so we want to keep it as a function instead of a fixed value. Fine, clear? The requirement is clear. Okay, fine. Let's look at the code for the account class maybe, and then okay, so account class, I think more or less the code is fine. Okay, we have made balance to be a default rather than a private. Okay, let's then go for current account class. Yeah. Okay, fine. This is the current account, and here we know withdraw method has been overridden, and it will use withdraw method according to the superclass. But then we have this penalty here. The penalty here is a static value. Okay, maybe we might also think about, instead of keeping the same penalty, penalty would now be a function, right? So we don't want the penalty function to be the same for all the current account. Okay, maybe we would like to have a different penalty function for a different current account object. Okay, but it is a feature of the current account and penalty function, it's not of the account. Okay, it's only for the current account, the subclass of account. Okay, so one thing, yes, here we want each individual current account object to be having its own penalty function. Okay. Fine, so one thing, penalty as a function, right? That's the first requirement we have. Okay, so how do we go about it? We want penalty as a function. That means we need a functional interface. We can use a functional interface because I want to have a function type called penalty. Okay, fine. So let's start with defining a functional interface. Okay, so yeah, and we can keep it part of the same package. So it can be part of the same package here. Okay, so we can keep it as okay, so let's start with this. So we'll say package, bang, and then we have a public interface, and this interface, let's call it as penalty. Okay, fine. So we call the interface where the penalty function will be stored as penalty, or you want to call it as penalty function, it can be fine. Okay, let's keep it penalty. And another thing which we know is for any functional interface, when you're defining a functional interface, okay, you can use, this is optional, you may use a annotation called @ okay, @ functional interface. So you can use this annotation whenever we are defining a function interface. Okay, yeah. So what is the function we want? We want it as a function of, okay, so yeah, we would like to keep a function, so we can have a public method, okay, for the function which it is to define. What will the function be doing? It will be computing the penalty amount and returning the penalty amount. Okay, so the return type can be long, right? Method name can be compute maybe, and the parameter to that, this function will be a function of minimum balance and the required balance. So we can keep long minimum balance as a parameter, and another parameter can be long for the balance fee. Okay, fine. So this is what is the requirement for defining a function interface. There is only one, and here what we have is we have only one abstract method. Okay, this is a function interface since it has got only single abstract method. Okay, fine. So one thing is we have a function interface called penalty now. Okay, let's save this work. Okay, and we'll save it as, okay, so we have an interface called function penalty. So penalty is now a function. Okay, we have defined this, now we have to use it now, right? So this is a function, it's a very simple function interface which we have created, and we would like to use it in the current account. Okay, let's see how it will be used now. Okay, so yeah, so now what we want in the current account, yeah, what do we have? We have this static variable for minimum balance, we keep it as it is, but we don't want to now have penalty as a fixed value. Okay, right? Instead, we would like to have as individually for each current account object, there might be a penalty object, right? So the penalty function has to be there for each and every current account. So we'll say, okay, this has a penalty. Okay, so there is one object of the penalty function. Okay, and let's just call it, the variable name can just be called as penalty. Okay, now you can, if you want, you can put some initialization here itself and say, okay, I would have a penalty which is something like this, right? So you can have your own. So how do I write a penalty function? Yeah, how do we write the penalty function? Oh, it requires, here we can use lambda expression. Okay, since this is a penalty is a function interface, we may use a lambda expression. We'll say, okay, we have long. Okay, so one of the thing is here, it's the minimum balance, and another long for the balance, right? And we can have a lambda operator here, and yeah. Now one of the thing, okay, let me put the full form of the lambda expression here. Okay, so in this, yes, how do we compute? Maybe it should always return a 0. So by default we are saying, okay, we have a penalty function, okay, which is always returning a 0. Or this could also be the case. Okay, you may even write a, so this is your, so this is the default. Okay, this is by default. What is the penalty? What is my penalty function? The penalty function always returns a 0. Or maybe you want to say, it should always return 100. Okay, if penalty is there, it should always be 100. No, it's not a good idea to just say return 100. You want penalty to be 100, but then instead of relying on someone specifying, okay, that I need the penalty value to be computed, okay, whether penalty is applicable or not, that must be checked first. Okay? So only in case, okay, only in case balance is less than the minimum balance. Okay, those two parameters are there. We know the balance, we know the minimum balance. So if balance has gone below the minimum balance, okay, fine. In that case, we can keep 100, otherwise a 0. Okay. Fine. So we are having a, this is exactly what it like, okay, one thing here, it is almost equivalent of putting the, okay, so we are putting this, yeah, it was 200, we can keep 200 here also. Yeah, okay, so this is now almost equivalent, but only one thing here is, this is as an instance variable rather than a static variable. Okay, and we have a variable called penalty, which was earlier also there. Penalty was a variable, but that penalty variable was of type long, but now the penalty variable is of type penalty, which is a function. So we are saying penalty is nothing but a function now. Okay, suppose we make this change. Okay, right? So one thing here is, how do we use this penalty function in the computation of penalty? So one thing here is, oh, this is the case where the penalty was to be applied, right? Okay, so minus equal to penalty, but no, penalty is not a long value. Instead of this, what should it be? Minus equal to penalty dot compute. And what is the minimum balance? The static variable is called minimum balance. Comma, and this dot balance, you can say this dot. So call the compute function on the penalty object. Okay, so this should be able to compute the penalty. Okay, fine. By default, we currently have a fixed penalty function. Okay, we have defined a function and kept it with the penalty object. Okay, so yeah, with this, things should still work the same. Okay, result wise, it should give us the same results. So penalty, instead of being a fixed value, only thing is we are able to call a function to compute the value of penalty. The function, whatever it may be, right? Function currently says, okay, I will compute it as 200 if it is applicable, otherwise it's a 0. If balance has gone below minimum balance, oh, we are making it 200. Okay, but we can have our own. The idea here is we will be having our own function. We'll see how we can use it now. Okay, so one thing is this. Okay, I want to first test it out whether this is working or not. Okay, so first thing, yeah, we'll see the test account whether we are able to get a penalty applicable or not. So we will have our test account. Here is the test account. What have we done in the test account? We have created, okay, we created account objects. Oh, AC1 is a current account object. Okay, AC1 dot withdraw. If not AC1 dot withdraw 2 lakh, oh, that was insufficient balance thing. Okay, we only withdraw 20,000. It doesn't go below the minimum balance. Okay, we didn't check the computation of penalty earlier, but anyway, it would work properly. Okay, so AC1 currently is a, okay, I think we can run it and just check what are the balances, and at the end let's try to, okay, so now here at the end what we'll do is we'll try to get the penalty. Okay, we'll try to apply the penalty here. Let's, okay, so first we'll try by just saying, okay, AC1 dot display. Okay, let me check what it is, and then we'll add the code to do the next steps. Okay, let's check the what is the balance currently, and then, okay, fine. So now here, let's compile Java C minus D dot dot backslash bin in test. We have the test account dot Java. Okay. Okay. Yeah, I think we forgot the semicolon here. It was an assignment statement. We had to finish the assignment statement. Okay. So now this is compiling, and then we can run the code. Okay, let's check. So yeah, the balance is 1,30,000. Okay, so fine. So what we do is we'll add, okay, so after displaying this, fine, now let's have the penalty. Fine. Fine. Minimum balance was 10,000, right? Okay. If minimum balance is 10,000, AC1 dot, okay, I think we can copy the statement which we had, the if statement which was written earlier. Okay. So if it can't withdraw, yeah, but how much to withdraw? We can withdraw. It's 130, we can just say 125. Okay, so then this should go below the minimum balance. And after this, again, we would like to do the display. Okay, see what we are doing is we have displayed once, this was done earlier. Now we are trying to withdraw 125 and then displaying it. Okay, so let's compile and run this code. So you can see we have withdrawn 125, but the balance has now become 4800. Okay, so 200 is the penalty amount which has been deducted. Okay, fine. So we are able to manage penalty as a function, and we have kept a function object, and that is also working. Okay, fine. So now next thing is, okay, so next change, let's come to the next change which we should be doing. In the current account, we have penalty as a variable, which is an instance variable. So it's actually a good idea to have a getter setter for it. So we can say, yes, someone wants to change the penalty function, let him be allowed to change the penalty function. So for that, yes, what do we do? We'll say, yes, we have a public method. Someone wants to know what is the penalty function which is applicable to a particular current account object. You can get that penalty function. Okay, so we can use a method called get penalty. Okay, and this is a simple get method, just like any other instance variable we have written, like get account number, get name, get balance. Same way, get penalty, because penalty is a variable for me here. Okay, and we'll say, okay, we can return this dot. Okay, and so we are returning the penalty function. Okay, just like we return the penalty function, we can also have a function, a method by which a new penalty function can be set on the object. We'll say, okay, we have the method called set penalty, which takes a penalty object. Okay, so this is simple. This dot fine. So this is the get and set method for the instance variable which we have. So we have an instance variable called of type penalty, and we are saying, okay, we would like to have it as we would like the idea of being able to change the penalty function or on a particular current account object. Okay, so with this, let's see how it makes a difference to us. Okay, so now with having a setter method, yeah, what's the next step I should have? On account 1, I should be able to say, oh, we have account, which is the other current account, because now we should work on the other one. I think if I look at the output, we should be able to see there is another current account object, which is for John, right? And that is having a balance of 1 lakh. There's another one for Martin also. Anyway, so we'll try with this current account for John. Okay, we'll try something on that also. Okay, so maybe for John, so the one for John, which is, what is it, AC3 is for a savings account, right? AC3 is a savings account, and this is a different one. Okay, AC, there is one AC, I think. This is for John, right? Yeah. So on AC, let's try AC. So we can say AC dot set penalty. We want to have a different penalty function. Okay. And what can I pass as a penalty? What do I need? Someone says set penalty. So in set penalty, what is needed? A function, right? We can just pass a penalty function. So here is where we can again use a lambda expression. Oh, here is my function which takes long minimum balance, another long for the balance, okay, and I can write a function here. So I'm writing the function which is to be used for, okay, yeah, okay. So what goes in this function? Return. Yeah. First check about when you want to write multiple statements, want to use it like this. Maybe you want to write a function which looks like this. Maybe you'll say one thing is if balance is greater than or equal to minimum balance, min balance, right? Min val, that's the variable. Yeah. If val is greater than or equal to min val, okay, in that case, I want to return a 0, that's fine, okay. Otherwise, if, okay, let's compute now. Okay, let's do some computation like this. We'll say long, okay, difference, okay, what is the shortfall basically? Equals, yeah, minimum balance minus the balance. Okay, minimum balance minus balance, we get a difference. What is the shortfall he is having? Okay, and if this difference is greater than 500, yeah, no, I think if this, we have 10,000, right? So if this difference is greater than 8,000, okay, then I would return maybe 800. Okay. Right. Same way, if the difference is greater than 5,000, okay, we return 500. And if the difference is greater than 3,000, okay, we return 300. And otherwise, we simply return 100. Okay, right? So we have, based on what is the shortfall, okay, we have a different value for the penalty amount. Okay, so someone may write to have a function like this. The idea was this, that penalty is not a fixed value, but it is rather a function of the minimum balance and the balance he is now got. Okay, so this is just one kind of a function which we have written, another way of writing the function. So there is a different account object, this is AC, on which we are saying, okay, I want to set this penalty. Okay, and then AC dot display. Oh, we have to withdraw, right? Sorry. Oh, we have set the function and now saying, oh, let's not write and see the withdrawal. If it withdraws with penalty, okay, I think for withdrawal we can just have this one. So in case, because it's returning a Boolean value, right? We can make use of it here. If AC dot withdraw, it's 1 lakh, right? So we can just say, okay, I want to withdraw up to 96,000. Okay, maybe I withdraw 96,000 here, and then AC dot display. Okay, let's check what is the balance. Yeah, anything wrong with this code? Will this compile? it's not related to the lambda expression which we have used. Okay, it's not about the lambda. There's no problem with the lambda expression. But yes, there is some problem somewhere. And it's this line only. Okay, see, I'll show you what it is. What are we doing? AC dot set penalty, right? Let's see what is the type for AC. From compiler's point of view, what is the type for AC? It says AC is of type account, right? AC is of type account. And do we have set penalty in account class? Is this available to me in the account class? It has been defined for current account, not for in general for all account. Okay, so but I know that AC will be having a object of current account. So what you will be required to do is the casting. Okay, so we need to cast AC as current account in order to use the set penalty method. Okay, so set penalty method can be used here, but for that, yes, casting will be necessary. Okay, fine. So now let's try and run the code. Okay. Oh, fine. I think what is the penalty applied now? 3,700. He has 1 lakh, right? And we said withdraw 96. So I think the penalty which has been applied is 300. It seems to be, yeah, because 96,000 means only 4,000 should have been left. What was the difference? What is the shortfall? 96,000 and yeah, let's go through this. Yeah, balance greater, no. So difference is 6,000, right? I think the difference here turns out to be 10,000 minus 4,000. That would be the 6,000, right? So this is 6,000. Is it greater than this? No. So is it greater than this? Yeah. It should have been how much? And it should have been, difference was 6,000. Okay, this is 6,000, greater than 6,000. Yeah, okay, so it doesn't go here also. And 6,000 is not greater than 6,000, and therefore it would now compute according to this. Okay, so this is, and that's how the 300 was calculated. Okay, basically I wanted this was 800,000, 6,000. Okay, that's fine. Okay, fine. So it has computed according to the function here. Okay, fine. So we can see this, that penalty is now a function. Okay, fine. A few things now. Fine. So is this okay? Clear? Fine. What we have, what we wanted to do, right? We wanted to have something as a, not as a fixed value like data type of long, but rather a function. And how to write function? Or this is how we write a function. So now let's talk about a little more about the lambda expression. Okay, so let's come back to this and see lambda expression. Okay, so there are a few, why I'm coming back here is there are a few shortcuts here, okay, which are applicable to a lambda expression and which we could have used here. Okay, so in a lambda expression, Okay, in a lambda expression, okay, the type of the functional interface, right? The type of the function interface is known, okay, or it is determined from the context in which it has been used. Okay, so in that context, a function interface must be present. Okay, it should be of a type which is a function interface. Okay, right. Only then we can have a lambda expression. Okay, so in this case, when we are writing a lambda expression, we understand the type is going to be penalty. Okay, now since the type is penalty, okay, okay. Since the type of the function interface single abstract method the single abstract method signature is known. Okay, it's known to the compiler. Right? When compiler is compiling this code, it knows, yes, this is used in penalty context, and in penalty, the function takes two long values as a parameter and returns a long. Okay, so single abstract method signature is known to the compiler. Okay, so it is not necessary to specify, okay, to specify the type of the parameters. Okay, so for example, okay, okay, I'll just give an example like this. Let's use that penalty interface only. Penalty P equals, suppose I'm writing the penalty as a function, right? So I would be able to say, instead of saying long and then saying min val, comma long val, and then writing a lambda expression like this, it would be possible for me to just say, just use the variable names. No need to specify the types. Okay. Fine. So this is one aspect. Okay. And then you write your function, right? Okay. Fine. So then we are writing a function which is returning. Okay. You might have some more code also. Yeah, you could have any number of lines of code. So there is some code maybe, but then you're saying return some expression of type long. Okay, some valid long expression. That's what is necessary, right? So this is the syntax, right? So its syntax has changed to not specifying the data type for the parameters. Okay, a small variant. Let me just also explain now. Again, related to the parameters. Okay, when we write the parameter list, in case of a lambda expression with single input parameter, if there is only single parameter where type of the parameter is not mentioned, then the parenthesis for the parameter list is not necessary. And now I'll have to take a different example instead of penalty, because now we are talking of some kind of a function which takes only one parameter. Okay, we have two parameters in case of penalty. Okay, when our method is compute which takes two parameters, but now if we had some other function, if there was a different function interface, so single parameter interface, I can take an example from the API. Okay, and for example, there is an interface called predicate. Yeah, we have an interface called predicate of, okay, it would be generic, so let me not use that. Maybe there is something called, there's an interface called action listener. Okay, there is one interface called action listener, and this action listener interface has a method, okay, which returns void. Name of the method is action performed. It takes as parameter action event. Okay, so currently don't bother about what is an action listener. The idea was only to give you an example of a function interface. So this is a function interface which has only one abstract method, and that abstract method happens to be like this. The point here is this has only one parameter. It's a function with only one parameter. Okay, so yeah, so when we have something with only one parameter, okay, while writing a lambda expression, so for example, I'll say, oh, I want to have an action listener function. Okay, action listener 1 equals, and oh, I know I could have written something like this, action listener and I could have said AE and then written the code for this. Okay, so instead of all of this, okay, we understand we don't need to specify the type here, so we could have written like this. Okay, not only this, here the parenthesis, because only one parameter, you may write like this also, and then write your function. Okay, fine. So this is one another aspect. This is related to how the syntax for a lambda expression. Lambda expression types for the input parameters not necessary. Okay. Other thing is, if there's only single parameter, you are not mentioning the type, even parenthesis not necessary. Okay. A third thing is related to the body of the lambda expression. Okay. If the body, okay, has a single statement, okay, so put it in a block. Okay. Okay. Not only this, but okay, when we have single statement, to be a return statement. If it happens to be a return statement, okay, then the keyword, only the expression should be returned. Only the expression must be returned. Fine. and you should not be writing the return keyword. Okay, and for example, we have written some place where we said, okay, I think in the declaration we have said, we had used like this, right? If you recollect, penalty equals, and then we had written the whole, so now I'll give a new version of min-val, val, and then we had that, we have said it is a return statement, so don't use the keyword return if it's only a single statement. And then we have something like this, yeah, if balance is greater than, yeah, I think it was like this, if balance was less than the minimum balance, okay, question mark, in that case it was 200, otherwise 0. So yeah, don't say return. The idea is you don't put the keyword return. Find the statement, if it was in braces, I would have written return all this. So if it's in braces, see, earlier case was, it was like this. Okay, this is how it was written. So since it's a single statement only, we are removing the braces. But when you remove braces, if it happens to be a return statement, then this cannot be specified. You just only have to mention the expression. Okay, fine. So that's how you write a lambda expression. Okay, clear? How to write a lambda expression? So lambda expression for function interfaces. Okay, so we can use lambda expression wherever we have a function interface. Okay, fine. We can go back to that function interface and see what else can be done in the definition of the function interface. Okay, so what is a function interface? What is a function interface? An interface with only single abstract method. Fine. So here is my example of a function interface where we have one abstract method called compute. Okay, it only says that it must, as far as abstract methods are concerned, there must be only one abstract method. Okay? It doesn't say anything about the default method or the static methods. So in this interface, we are free to have even static methods, or we can even have a static variable. Okay, for example, someone might say, oh, let me have a public static final, and the type of the variable, maybe I might like to keep a variable of type penalty inside the penalty itself. So I want to say, I want to have a penalty, and I would like to call it as 0 underscore. So there is a 0 penalty function. Sorry, there's a type. So the name of the variable is 0 underscore penalty. The idea why I'm putting all capitals, this is something which is a convention we normally follow. If we have a variable which is final, if there is a variable which is final, the convention is to use all capital letters. And if there are multiple words involved, we separate them with an underscore. Okay, this is the convention for final variables. Okay, right? We call them as constants. So here is a constant, a 0 penalty, and we'll have to assign a value to it. Yeah, so here we can use a lambda expression. So what will be the lambda expression? Okay, fine. We can just say yes, it's always returning a 0. Okay, and so this is one thing. Okay, so we are in this interface, fine, we are enhancing the interface. We added, someone wants to use this, right? So someone could always say, oh, ac.set penalty, and use penalty dot. So what is valid now? Because of this, what becomes valid? Okay. So I'll just put the code here so you understand what this enables, right? So this is enabling me to use something like this. Okay. AC dot set penalty. Oh, sorry, AC should be of type. So if AC is of type current account, so okay, whatever it may have been done, okay, it would be possible for someone to say AC dot set penalty. Okay, AC is of type current account and set penalty is available on current account. Here I have not kept it as of type account here. Okay. Okay. So set penalty will be able to take as parameter okay, so this becomes valid. I've made it easier. You don't want to, so you are making certain constants available to the user. Okay, so the one who is defining penalty, he is not only going to put the abstract method, but he will give some convenient things for the user of penalty. So he's saying, okay, you want to have something like this? Okay, fine. You could even be adding methods, static methods. Let's see if we can make some useful static method. Okay, so we can have a static method here, which is giving us again an object of penalty. Okay, so here is a static method which can create a function for me. Okay, I call the method name as fixed. Okay, and takes as parameter the fixed amount, penalty amount. Okay, let's call it PAMT. Okay, penalty amount. So given a penalty amount, I want the penalty object, which will always give me this value, right? Okay, so this we have to write. So here is a method, static method, which is taking input as the penalty amount, and it has to return a penalty object. So how do we write this code? Okay, in this method, yes, what should it be doing? It can simply say return. It has to return a function. Okay, the function is nothing but minimum balance, comma balance. Okay, and here what do I write? If balance is less than minimum balance, sorry, if balance is less than minimum balance, in that case it should return the amount, otherwise return a 0. Okay. Fine. So see lambda expression being used in a return statement, because the type of the method, the type return type is a function interface type. This is a function interface type, and we can use lambda expression for it. So when what it has to return, it has to return penalty. What is it? It's a lambda expression. It's a function, and therefore for function we have a lambda expression. Okay? Right? So like this, you can add functionality to your, make your function interface much richer by giving such additional methods, right? You can have additional method, additional variables. Of course, you can't be adding another functional interface. Sorry, another abstract method. So abstract method is only one. Okay, that is the whole point. Yeah. Right. So any questions about this functional interface? So using functional interface, right? See, I'm not making the changes, but you could try out. Okay. Example, right? So you could try out more things, fine, adding more things into the function interface here. Okay, penalty function, you can experiment with this. And another thing, yes, here also you can try experimenting. Okay, so, and for example, what we have done here is we have done the, okay, we have seen withdrawal on AC. So AC dot display, and then again you may set a different penalty function. You could say AC dot set penalty and have a different penalty function, and then see how the withdrawal works. Okay, how it is computing the new kind of penalty which we have. Okay. So you could try more things on this, right? Okay. Okay. So any questions? Yeah, you'll be able to try the things, and I want you to experiment with this account class, and maybe add more to the penalty function which we have written, the penalty function interface. Okay, this is the penalty function interface, and I have just shown you that yes, you could be adding static methods. So you may add more static methods to make it much richer. Okay, so when you write your function interface, anything which you are defining, just think about how it can be better. Okay, fine. What facilities I can give for anyone else who is going to use this class or this interface. Okay. And let's save this also. Fine. Lambda expression, how to write, that is also clear. So lambda expression is according to the abstract method. Single abstract method, yes, it is nothing but you can say one thing, lambda expression is an implementation of the single abstract method of a function interface. It is always nothing but in context of a function interface. So what is lambda expression? It is my function. Which function? That abstract method. Okay, that function is nothing but the abstract method which is in the function interface. A function interface has only one abstract method. And the reason why we want to have only one abstract method in the function interface, because that is what is being represented by the function. Okay. Okay, so now we know about the function interface, right? And writing a lambda expression. So any questions on this? Yeah, still? Is it understood or not? Yeah. Functional interface. Okay, you'll need to try out the things. Okay. Okay, fine. Okay, so let's take up the next thing again from what was done yesterday. Okay. We have this interface called comparator. Okay, we have an interface called comparator, right? Comparable, we had done yesterday comparable also, right? You recollect comparable we had done? Okay, an example for an interface was comparable, right? Where it is used, normally we will require it for sorting. The idea is nothing but providing the comparison for objects. Okay, less than, greater than, equivalent of those things in the object class for the reference data types, basically. Fine. We don't have such things for reference data type. Okay. Fine. Let's try to understand difference between yeah. So okay, let's begin with this comparable and comparator. Let's look at that topic again. There's a comparable of T and comparator of T. Okay, these are the two things. Okay, so what is comparable and what is comparator? One thing is, where is comparable? Java.lang package. And where is the comparator? It's a java.util package. Okay, and so this is one thing, yes, where they are available. The abstract method in both cases, let's see the abstract method for both. And so if I look at comparable of T, the abstract method here is returns int compare to, and parameter is T, okay, the element to be compared with. Whereas in case of comparator of T, again return type is int, name of the method is compare, but it takes parameters as 2 parameters. This is how that two are different, right? Okay, we can see this is how the method signature is differing for both of them. Okay, fine. So what is the difference basically? Fine. In this case, in the second case, comparator, it says you give me 2 objects. Whereas here it requires only 1 object. Why? Okay, look at the usage. The usage would be something like this. There is a dot compare to, where a and b are of type T. T is some type and a and b are of the same type, that is T, and we are saying a dot compare to b. Okay. Now here is another example how comparator is used. We'll say c dot compare. C is not of type T. C is not of type T, and we are saying a comma b. A and b are of type T. Okay, this is what we how we look at it. Right? I mean, the difference is like this from the usage point of view. So given a comparator C, okay, given a comparator C, okay, so C says if you give me 2 objects, I'll be able to tell you according to my logic which is greater, which is less, and if they are equivalent or not. Whereas in case of comparable, we are saying this item is comparable. A particular thing is comparable and can be compared with anything of a similar type. C is not saying that. So comparable is something which has to be an interface implemented by a class, which wants to say, oh, I have a natural ordering and I can be compared, objects of my class can be compared with another object of my class. Okay, whereas comparator is not about that class itself. Comparator is outside. Fine. In case of comparable, it is there itself, right? It is with this object of this class that things will be compared with. Okay. Right. Account is saying I am comparable, whereas there can be comparator, right, which may even involve account or may be involving things which are not even comparable. Okay, maybe you have a comparator for color, right? I was mentioning about color, right? So maybe you have a class called color and you want to have a comparator for color. Okay, so if you want to have a comparator for color, yes, you will find an implementation of the compare method which compares 2 color objects on some criteria and returns a positive, negative, or a zero. Okay, and so that's how comparator can be used. Okay, and you have so we may have a see we have a class implements comparable of account. Okay, so we have a class which implements comparable of account implements comparable of account. Okay, fine. The comparison logic for comparing by so natural ordering is being defined by it. Okay, fine, but account itself can be compared on other logic. Okay, okay, for example I might say okay, yeah, one thing, let's try looking at first the usage of comparable. I think we have seen yesterday and we have seen it in the sort method. Okay, so arrays class, okay. Arrays has overloaded it has overloaded sort method. So we do have, so I'm just giving other example of sort method. So we have a okay, so we have something like this: public static void. Now before void I'll have to put the type parameter t. It's a generic method. Name of the method is sort. Parameter is array of t, that's the array, but it takes a comparator of t also as a parameter. So that's my comparator. Okay. So you're saying sort the array, okay, but when you have to compare two elements in the array, use the logic which is available from the comparator. Okay, fine. For how do I compare two elements? If they are numeric types, we know there is less and greater than, right? But in case of any other thing, where is the logic? How do I make the comparison? So that logic is going to be available in the comparator. So that's another way of sorting. So if you want to sort those account objects, okay, fine. How do I sort that account object? Okay, so I want to sort by some other criteria. Maybe I want to sort by balances. Okay, what I should be doing, right? Okay, fine. So let us look at it in the example and in the code itself. what we will need to know, yes, we will need to know the method signature of comparator. Right? This is what we'll be requiring, right? We need to have a compare method, and we understand comparator as a function interface. Right? Comparator is a function interface. Okay, and that's a method signature. Two inputs, returns int. Okay, what is necessary? Oh, it takes two elements of type t and returns int. Okay, let's go back to the test account class. Okay, right. We were sorting earlier, right? The place where we have done the sort. Okay, after sorting, yeah, we have done this after sorting. Okay, so let's copy these three statements. Okay, maybe I'll put it at the end again. So yeah, let's do a arrays.sort. Now instead of this, we now have to, so when we do this, only one parameter, if we only give the array in the sort method, it sorts by assuming they are all comparable. Okay, but now what we also have is the option of specifying a comparison logic. Given two account objects, tell me which is greater, which is less. Okay. So we can do like this. We can say AC1 dot get balance. Okay, I think what I'll do here is I'll put this in a new line. Okay, that's my second parameter. Okay, so I have to return integer value. What is AC1 dot get balance? The type is long. Okay, I can cast it into to make it a reference object. Right? I want to create object instead of having the primitive value long. Oops. Yeah. Okay, this thing. So this thing has been cast as a long dot. When it is long, we understand they are comparable. Wrapper classes are comparable. Okay, since wrapper classes are comparable, we can say dot compare to. Okay, and what's the next thing we compare to? AC2 dot get balance. So comparison based on balance. Okay, end of the sort method. This is it. Okay. After sorting by balance. Okay, what have we done? Okay, AC1, yeah. AC1, AC2, those variables can't be used because they are in use as a local variable in the method. So let's make it A1, A2. Okay. And then let's run the code. And at the end, you can see after sorting by balance, right? And the one with the least balance comes first, next. So this we can see they are ordered by the balance. Fine, clear? See, clear with the meaning of what is comparable, what is comparator. Fine. How the two are different. Okay. And how do we sort by using comparator. And this is where we have used comparator. Okay. And this parameter here is a comparator object. Comparator is a function interface, and we could write a Lambda expression. And later we will find there is much simpler way of doing the sort method. Okay, this sorting which we wanted to do, I'm not currently going into the syntax, but equivalent of this, these three lines, okay, what we could also write, okay, and this is going to work, but I'm not explaining it currently, okay, because we are using one more concept, but you will realize how simple it can be. Okay, now instead of that Lambda expression which I have written, I would actually be writing comparator dot, because like we have added what static methods in the penalty. Same way, this comparator, which is a function interface, it has added a lot of static methods which help you to create a comparator object. Okay, so you could say comparator dot comparing long. Balance is of type long. So we are going to be comparing something which is of type long. Okay, and from where do I get that long value? For each account object, and this is also true. Fine. So you can use either of them. Okay, see, this looks much simpler. In line 6 you can see comparing long, and that long is nothing but what you find as the get balance method of the account class. By applying the get balance method of the account class on the two input objects. What we have used, that double colon, is a new syntax, and I'm not discussing that syntax currently. We'll later, after studying more on the using, once we get used to using the Lambda expressions, okay, then we'll see there are cases where instead of a Lambda expression, okay, not all cases of Lambda expressions can be converted to something like this. We can get it converted into what we call as a method reference. This is what we call as a method reference. Okay, so that's an example of using a method reference. Want to check this? You can comment it out. Okay, and maybe just we need the import for the comparator. Okay, it's from the java.util package. Oops, we need to compile. Okay, and then run. And same result. Yeah. So any questions now? Lambda expression, I think, is the Lambda expression part clear? Lambda expression is nothing but a function object. how to create a function object. Function object only for the type which is a function interface. Fine. What is a function interface? An interface with only one abstract method. Okay. And interfaces can have abstract method, default method, and static method. Fine. Any questions? And push them. Okay. Yeah, any questions? Okay. Anything which is difficult or something? Want to repeat something? Any concept? Okay, fine. So our exercise so far, fine, what we have done in this exercise is so far mainly related to the class called account, right? Okay, so we have been able to define a class, we have been able to create subclasses, right? We have an abstract class, right? And today we also did a functional interface, right? Use the functional interface in the current account class. Okay, fine. We can enhance, you go ahead and make changes to this and try out. Okay, fine. You should try basically. And unless you try, you will be able to get the confidence on all this. Okay, so make changes to whatever I am doing. Fine, make your experiments on this. Okay, fine. Experiment, that's the only way to learn more. Okay, and unless you experiment, you will not get questions. Okay, fine. Next, what we should be taking up, fine. We'll revise that generic thing again. Okay. And again, a short revision of the generic thing. Okay. And then proceed to the next topics which are related to, or I think, okay, I think we can take up the next topic. One is related to the nested class. Fine. We can have a look at the nested types. That's the next thing we can do. And there's another thing called exceptions. Maybe we start with exceptions first then. Yeah. Okay, so next topic will be related to exceptions. Yeah. So let me put it here. So next will be so next topic on exceptions. So tomorrow we should be starting with exceptions, but you should try out all this code. That's one thing. You need that you should try out all the code. Okay. Okay, thanks. So tomorrow I think we'll get started with the exceptions. Okay, what is an exception? And try to understand. What we'll try to understand tomorrow will be about okay. How all your things execute, right? The code which you are writing, how it is executing, what is necessary. So it will involve knowing about two things. Okay, runtime stack, looking at what is the runtime stack and heap. Okay, these two things, yes, we'll have to look at. Okay. So next is on exceptions, and that we will take up tomorrow. Right? So if you want, yeah, you can read about these things also, right? Okay, so if you don't have questions, yeah, we can break for the day then.